Hello, my name is Paul. I'm with PKH Lineworks. Today I'll be demonstrating our newest Revit extension called Paraline. So what does Paraline do for you? While Revit is very good at doing 3D modeling, its drafting views are very limited. Revit doesn't have commands like AutoCAD's isoplane and isocircle. And if you want to reuse 3D views between projects, that's only possible if they're drafting views. So there's a gap here. Basically what Paraline does is it helps you convert orthographic drafting views into isometric drafting views and greatly decreases the amount of time it takes to create your isometrics. So here are our details. We have a section cut through a metal stud bulkhead with some steel supports on it, and this in front is a sign band. Over here we have a plan view of this connector detail on top. We're going to merge these two into a single 3D detail that looks something like this. Now, when I created these details here, I used Revit standard detail components, gypsum wallboard, steel channel, angles. This is a filled region. First thing we need to do is to convert the detail components into filled regions. Normally a big deal, however, we have a tool for that now. If I go down here, I'll pull down the Paraline toolbox onto our view so we can use it easily. I'll just select everything and go explode detail component. It'll chug for a bit. And basically what this does is it imports all the lines and filled regions inside the detail component family. Here it shows I have 11 of 11 successfully completed. And I'll say yes, delete the original components so that I'm just left with filled regions and lines. Masking regions are not yet supported. This is a limitation that Autodesk API has. So masking regions are converted to solid white filled regions so that we can work with them. And I'll just do the same with this one here. Anything that's not a detail component is automatically filtered out and unaffected, of course. You may see some lines come through what were masking regions at one point. The order just has to be modified and it'll hide these again. And there we go. Now everything's been converted nicely to filled regions. You can see here new regions that don't already exist in the project are automatically created and prepended with the PKH initials so that you can easily find out what's been created. There's a solid one that replaces our masking regions. Steel was also created because these did not already exist inside the project. They were only inside the detail components. So now that we've converted all the detail components to lines and filled regions, we can convert this to a 3D isometric. I'll just begin by selecting all the components that we want to convert. Begin the ortho to iso command and we'll see the interface come up. And I'll just explain this for a bit. There are 3 buttons here for you to select which side or top view you want to convert to. Outline region will add detail lines around filled regions. This can be handy sometimes because you're usually stretching these out into a 3D view and need some backup lines for that. Delete originals will delete all the original components after they are converted. We want this for this case, and I'm going to convert this into the left side, left facing face. We just click that and there we go. All the filled regions have been converted into the 30-degree isometric view for a left-facing side. Just select these break lines, get rid of them, and I'll convert this into a top view. Short lines, we get this error sometimes when there are lines that are too short once they are converted. These lines will be ignored. You can see which ones they are. They'll still be highlighted and selected after the conversion. You can see it doesn't impact the overall view, so I'm just going to hit delete, get rid of those, because in the detail view, very short lines aren't too important. And then we can begin to merge these two into a 3D isometric. You can begin to see our top view gives us depth, while our side view starts giving us height data that we can extrapolate from and convert this into a 3D isometric. So for this next part, I'm going to finish converting this top bracket assembly here into an isometric, but for the rest of the detail I'm just going to speed up the video so you can see very quickly how it works and just to see what to do. First we'll just cut this back to make a nice corner on here. The bolt assemblies, we don't need the plan view of the bolt assemblies, we actually want to use the elevations, so we'll just take these out. Of course we want to align this up because this is a bent up portion of this assembly. You'll find this join helps quite a bit here, and this will actually appear back here. Should probably take these as well. And there was a filled region associated with these bolts that we don't need. I'll just filter out those, get rid of them, and just start layering up our information here. Add a little 3D to the flange and to the bolts. Here, I'm gonna make these about that deep, and you just start drawing in the depth. Unfortunately, I can't make a program to do that part for you. Anything hidden by the front of the bolt should be removed. Quadrant points on ellipses help quite extensively for this. And with the slice command I found, use the delete inner segment. You'll see it snaps to endpoints of lines and intersections where you want to do that, and we can just cut that out. Start peeling things back so that yeah, you can see it's beginning to take shape. This of course wouldn't be seen here. This won't be seen, so I'll just get rid of this for now. If it wants to slice to the right line, just tab and it'll slice the intersection point of the two lines. Very handy little tool they've added in for Revit. And there you go. Just draw in a quick little nut assembly. We need to increase the height. So we just take these lines, copy them up, and of course the lines that are hidden you want to delete. And you can begin to see how it starts forming out and filling in information. This doesn't look quite right. And there you can see the 3D information starts to come in. I did a little bit wrong here. This needs to be moved up as well. There we go. So you can see the top plate is starting to take shape and look more 3D. We don't don't need that line, it shouldn't be seen. And there you are. I'll do the rest of the detail very quickly without commentary and just speed up the video so you don't have to sit around. It's just more of the same of what I've just did. So there you see our finished detail. I didn't go into quite as extensive detail as I did with the previous example I showed you. Just wanted to put a few final notes into this video. The ortho to ISO also works within family documents, so this will help you create isometric detail components if you'd like. It works with all flavors of Revit 2014 and 2015. You'll find this on sale at the Autodesk App Exchange. I'll post a link below when it has finally been approved and gone up for sale. And if you would like more information, visit us at www.pkhlineworks.ca for more information. Thanks. Bye.